today what are we going to do? Today we are going to start with our group 18 elements. Yeah, group 18 elements. So which is the first element of group 18? Kevin and Sarjana, Gopul, Gopinath, Ragul in the chat box. Come on. First element of group 18. Kevin, which is the first element of group 18? Group 18. Yes, Archana. Which is the first element of group 18? Good evening, Prashanti. First element of group 18. Group 18 is the last group. Yeah, last group of the periodic table. Yes, correct. It is helium. Correct. It is helium. So we have group 18, that is nothing but helium, neon, argon, krypton, xenon. Over here it should be helium is 2, it should be 10, not 7. Okay, 2, 10, 18. I hope you all know how to write down the atomic numbers. Yeah, how to, like from the first element we know that how to write down the atomic numbers. Correct. Then your noble gases, what we are going to study about today, all the properties, some of the reaction. Now you have studied that noble gases are inert. Okay, Prashanti, you must have studied that noble gases are inert, that they do not react. But Kevin, your whole life was a lie. Yeah, they are little bit reactive. They are little bit reactive. You have reactions of group 18 elements also. Okay, it is not that they are completely unreactive. We always say they are the least reactive or less reactive, but some reactivity is there. Okay, they are not completely unreactive. Okay, there are compounds which react with your group 18 elements. Now this monoatomic, can anyone tell me what do we mean by monoatomic? Yes, Sarjana and Ragul. Anthony, good evening. Why are you so serious, Anthony? Smile.
Good evening, sir.
Good evening, Anthony.
Yes, sir.
Everything's fine?
Yes, sir.
Yeah?
Yes,
Why
sir.
are you so serious? Got
Nothing.
shouting from your teachers? Got beatings? Anything?
No, sir.
No, na? Okay, I hope you were there in the PTM.
Yes, sir.
Okay. I hope that is not why your face is upset. Yeah? No, na?
No, sir.
Okay. Thank you.
Thank you,
So
sir.
well, so over here, monoatomic. Oh, come on. Do not tell me one atom. You are simply translating it. Oh, mono means one. Atomic means atom. Yeah. Come on. Give me some better answer. What is this one atom? Like, what is even the meaning of it? One atom. Yeah. It is monoatomic. One atom. What? Like, does it even make sense? Kevin, Sarjana. Does it even make sense? Like, monoatomic. One atom. Make it make sense. Monoatomic. What do we mean by monoatomic? Yeah. What do we mean by monoatomic? Yeah. And you know the best part. The best part is I have right now 8, 9 students. All of them has a specs. Okay. All of them has a specs. And Ragul, if you try to search the answer on Google, I can see it in the specs. Yeah. I can see it in your specs if you just switch the tab. Okay, if you just switch the tab. Okay, Achha, this is for screen. Okay, the blue light emission. Okay, so if you switch the tab, I can see in your glasses. That does not mean from tomorrow onwards you'll start wearing the contact lenses. Okay, so then I'll get the tab and answer if you stop wearing glasses from the next class. Okay. Okay, they do not combine with others. Monoatomic. Okay, I'll give you hint. Then afterwards, you'll definitely give me answer. Oxygen is diatomic. Oxygen is diatomic. Yeah, oxygen is diatomic. Now, any hint you have got? Oxygen is diatomic. Yeah, Kevin? Any hint you must have got? Oxygen is diatomic. Yeah, oxygen is diatomic. Ah, correct. See, in the nature, exists as a single atom in the nature. Correct. So, see, I have already told you they are inert. They do not like to react with anyone. They are stable. You know, there are some students. No matter how much teacher shouts, no matter how much teacher scolds, doesn't matter, always in his own world. Yeah, same is your inert gases, always in his own world. Okay, always in his own world, because it is not reactive at all. Okay, so what happens, they do not combine with themselves also. Okay, so in nature they generally exist as monoatomic. Like if you have helium gas, you all must have heard about it. Yeah, helium gas, isn't it? You all must have heard about the helium gas. So we have a balloon of helium gas, isn't it? So that again, helium gas, oxygen gas, if we have to write, we write O2. Helium gas, we write it as He only, because in the nature it exists as He. Is it clear, everyone? Okay, this is what we are going to study as we go ahead, all the properties and everything. Interhalogen compounds, we have already studied in the last class. Yeah, sure. Let us go ahead and study our group 18 elements. Let us study our group 18 elements. Let us do the property first. Yeah. Let us do the property wherever we have this. Now, generally, they are colorless, obviously, sparingly soluble in water, odorless, tasteless. Helium is a gas. Okay. It shows good diffusion. Weak dispersion force. Yes. Weak dispersion force, because, yes, they are not reactive, so obviously weak dispersion force will be there. Low melting and boiling point. Low melting and boiling point. Okay. Now, except radon, all occur in free state. That means what? Radon is never in the free state. Generally, you get it from ore like that. Okay. It is not in free state. And your noble gases are very less. They are 1% by volume in atmosphere, and argon is the major constituent with the 0.9%. Okay, argon is a major constituent of a 0.9%. Then your radon is radioactive. Yeah, your radon is radioactive. Radon is radioactive. Okay, radon is radioactive. That means it is continuously decaying. Continuously decaying. And a xenon and radon, they are the rarest element of the group. Okay, you do not find them much, but yeah, they are the rare elements of your noble gases. Okay, then I hope each one of you now know how to write down the electronic configuration. Yes, Kevin and Sarjna, Ragul, Gopinath, yeah, Anthony, Sindhuja, I hope each one of you now know how to write down the electronic configuration. We have already done that. So if the question comes for the electronic configuration, the valence electrons, I hope no one will do the mistake now. Yeah. So those are easy questions. Should not go from your hand. Okay. Then the properties. See, it follows the trend. Same trend. Okay, same trend. Like atomic number, obviously forget about atomic number. Atomic mass as you go down the group increases. What happened to atomic radius? Atomic radius as you go down the group, Kevin, the size as you go down the group, does it increase or decrease? Yeah, as you go down the group, the size, does it increase or decrease? Correct. The size obviously increases. The size obviously increases. So you can see it is in the proper order: 120, 160, 190, 200, 220. Now radon, it is not written because it is radioactive. Very short half life. We do not able to study that. Okay. Then ionization enthalpy is very high. Okay, 2372. That is the third ionization enthalpy of some of the elements. Imagine, so high. Why? What can be the reason? Kevin, Sarjna, and Gopinath, Bhuvaneshwari, Rakul. What can be the reason why ionization enthalpy is so high? Yeah. What can be the reason? Yeah. What can be the reason? Sarjna. What can be the reason? Correct. And Bhuvaneshwari, what can be the reason? Sindhuja. Good evening, Kirtini. What can be the reason over here? Yeah. What can be the reason? Why? Okay. if you have forgotten about ionization enthalpy, what is ionization enthalpy? See, ionization means what? You are ionizing. Correct. Correct, Sajna. Ionization means what? We are removing one electron from the element. Okay. Enthalpy means what? Enthalpy is the energy that is required. Obviously, Kevin, if something is stable, yeah, something is stable, why it will give away its own electron? Yeah, if something is chill at his own place, why will he disturb his own chillness? Yeah. So similarly, your noble gas is chill, is enjoying at his place. Why will he disturb his stability? He will not. So obviously, he, that is your helium, has the highest ionization enthalpy because the size is small and it is stable. So it is very difficult to remove electron out of it. If you want to remove it, it takes 2400 kilojoules per mole. Clear? Then if you go down the group, yes, obviously your ionization enthalpy decreases. Why? Because the size is going on increasing, your nucleus and electron goes away, away, away. So it becomes easy to remove the last electron. So if it becomes easy, the energy required is less and hence energy goes on decreasing as you go down the group. Come on, give me yes or no. Is it clear? Is it clear? Okay, then we have the electron gain enthalpy. Over here, slight exception is there. Electron gain enthalpy, again, how much enthalpy is absorbed or given away, or how much energy is taken or given away when electron is added. Okay, so a slight exception over here, neon has the highest. Okay, neon has the highest. So remember that, write it down. Slight exception is there. Neon has the highest electron gain enthalpy. Neon has the highest electron gain enthalpy. Okay, neon has the highest electron gain enthalpy. Okay, remember that. No one will ask you this, but you should know. Okay, you should know. Now, let us go ahead. Ionization enthalpy we discussed. This is we have already discussed. Low melting and boiling point. Then what we have? Okay, not very reactive. Yes, obviously we all know group 18 elements, they are not very reactive. Inertness to chemical reaction. Yes, they are inert to chemical reaction. Completely filled valence shell. Very high ionization energy. We have already discussed. Electron affinity large, 0 or large and positive. Okay, not that much. See, this is what I want you to write it down. This is the first compound. Okay, there was a scientist called as N. Bartlett. Okay, there was a scientist called as N. Bartlett. He was the first one to study or to find out any compound or complex with the group 18 element. Okay, so what happened? He was studying an complex which included platinum hexafluoride. He was studying platinum hexafluoride. He reacted it with oxygen. He reacted it with oxygen and he found out that, oh, I am getting a complex called as O2 plus PtF6 minus. Then he was like, okay, now size of oxygen, if you notice, the size of oxygen is somewhat similar to xenon. Size of oxygen is somewhat similar to xenon. So he was like, everyone says that it is inert, it is non-reactive. Let me try. Let me try if it actually non-reactive. So he found out, no, it can also undergo reaction. That he found out a complex of orange yellow color. Come on, write down both reaction. Write down both the reaction. This was done by N. Bartlett. Come on, write it down and done in the chat box. Done by N. Bartlett. N. Bartlett. Come on, write it down. N. Bartlett. Okay. Then let us talk about each element. Xenon compound. Let us talk about xenon. Okay. Now,
last slide, sir. Please, 1 second.
Okay, write it down, Anthony. Come on, write it down and done in the chat box. Kevin is done. Those who are done, kindly write down done in the chat box. Write down both the reaction and write down the statement also. that it was the first compound of noble gas. Okay, Kevin is done, Anne is done, Bhuvneshwar is done, 15 is done. Shanti is also done. Anthony, is it done? Okay, sure. Let us.
Yes, sir. Completed, sir.
Yes, Anthony, is it done? No? Okay. Now let us look at the xenon compounds. Okay, let us look at the xenon compounds. Okay. So xenon compounds. So over here, these are some of the important compounds of xenon. I want you to write it down, but first let me do some corrections. Xenon oxidifluoride, XeOF2. Kindly find out the oxidation state so that we will know it is correct or no. Xe. Find out the oxidation state. Xe. Xe. What is the oxidation state? Kevin, Sarjna, Xe in XeOF2. Yeah, Xe in XeOF2. Correct? Correct, Sarjna, correct, Bhuvneshwar, correct, and it is plus 4, so it is correct, plus 4. XeOF2. Similarly, this is also XeOF4. Also XeOF4. Okay, XeOF4. Okay, and this is xenon tetraoxide. So this is XeO4. This is XeO4. Come on, write down all the compounds of xenon. Okay, write down like a table: +2, +4, +6, +8. So right now, I hope each one of you know how to calculate the oxidation state. Those who do not know, Ragul, look over here. I'll explain you once again. Suppose I have taken XeOF2, correct? So I am finding out, Ragul, the oxidation state, yes, for xenon. Presently, I am calculating it for xenon, correct? Kirtini, look over here. I am calculating it for xenon. So I'll take it as X, correct? Oxygen is -2 because charge on oxygen is -2. Fluorine is -1. We have 2 fluorine. So it is also -2 is equal to 0. So X minus 4 is equal to 0. X is equal to +4. Okay. This is how we calculate the oxidation state, those who do not know. Is it clear? Okay, come on, write it down. Write it down, everyone. Kirtini, 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 am I audible? Kirtini, am I audible? What happened? Last lecture also I caught you talking to someone else. Can we focus in the class? Kirtini? Yeah? Can we focus in the class? Okay. So, done? Okay. And is done. Bhuvneshwar is done. Come on, write it down, everyone. And done in the chat box. Done. Okay. Okay. Again. The VSEPR is back. Again, the VSEPR is back. Chalo. Let us do this. Yeah, let us do this. Let us do this. Okay. Okay, let us do this for this. XE, I hope all of everyone knows how to solve VSEPR now. Yeah? Okay, let us do for this. XeOF2, so that we can understand some of the exceptions also. XeOF2 and XeOF4. Come on, I want everyone to do this. XeOF2. What are you going to tell me? You're going to tell me about bond pairs, lone pairs, hybridization, geometry, and shape. Geometry and shape. Come on, every one of you, come on, try XeOF2. XeOF2. Come on. XeOF2. XeOF2. Come on. Calculate the bond pair. I hope everyone knows it. How to calculate. Yeah, Kevin, come on, give me a thumbs up or something that you know it. Kevin, do you know it? How to do VSCPR? Sarjana, I hope know it. Anthony, give me a thumbs up. No need to turn on your mic. It is fine. I hope you know how to solve VSCPR. Give me a thumbs up if you know it. Anthony, no, you do not know it. Okay. Kirtini knows it. Kirtini, okay. Sindhuja, okay. Okay. Don't worry, Anthony will do it. Ragul, do you know it? Let us some of the students solve it. I can solve it. Anthony, Ragul, okay, so that I'll help you with XeOF2. Okay? Just wait for a minute. I want bond pair, lone pairs, hybridization, geometry, and shape. Come on. We have lots of time today. Today we have group 18 elements. Very short topic. I have lots of time. Bond pair, lone pair. Okay, very good. And that's why, okay, do not forget we have oxygen in between. Okay, we have oxygen in between. Do not count that as, I am giving you a hint, do not count that as a two bond pair. Okay, don't forget that. Okay, I am sure most of you must have solved bond pair and lone pair. Okay, tell me how many bond pairs, how many lone pairs. Kevin, are you saying sp3d or sp3d2? sp3d. Okay. Sarjana, what did you get? Sarjana, do not give me sp4 like last time. Yeah, I remember hybridization called as sp4. I was like, oh, we have a new hybridization. Yeah, Prashanti, I hope you know it. All done, Prashanti. I hope you have energy now. Done with the food. I can see the energy. Come on, I want same energy in your fingers now to type the answers. Yeah. Last 5 minutes, Prashanti. Okay, I am discussing about VSCPR, Prashanti. Okay, I have told you to solve XeOF2. We did not discuss much. Okay, we did not discuss much. I have just talked about the overall compounds. Okay, we are doing now important thing VSCPR. We have to calculate VSCPR for XeOF2. I hope you know presently how to calculate it. You know. Okay. And you told me 4 bond pairs and 2 lone pairs. So how it is sp3d? Is it? Yeah, oxygen counted twice, no? I knew it. Yeah, 3 bond pair, 2 lone pair. Okay, chalo, very good. Very good, everyone. Chalo, look over here. Okay, this is where I wanted to help Kevin. How it can be like square pyramidal? sp3d, no, you told me, Kevin. So how it can be square pyramidal? Shape, it is TBP. Okay, so how it can be square pyramidal? Shape, no, not possible. Look over here. Look over here. Everyone, focus. Look over here. Those who have solved it, finally find the shape. If you know this, otherwise I am helping. Anthony, Ragul, kindly look over here. Okay, I want your complete focus. Anthony and Ragul. Okay, look over here. Anthony. Xe, how many valence electrons we have? Ragul, Anthony, in the Xe, that is your group 18. So valence electrons are 8. So Anthony, what I'll do? I'll draw the 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now I have oxygen and 2 fluorines, Anthony, correct? Oxygen make how many bonds? Single oxygen make, Ragul, 2 bonds, correct? So 2 bonds. So I'll draw 2 bonds over here, a single oxygen. That makes a single bond pair, okay, with oxygen. Then we have a fluorine. So 1 bond pair with the fluorine and another bond pair with another fluorine. That makes XeOF2 bond pair are done. So total, Ragul, Anthony, we have 3 bond pair. Is it clear till here? Yeah, 3 bond pair. And remaining what we have is the lone pair. So 1 lone pair and 2 lone pair. This is the lone pair. This is a lone pair. I am saying lone pair. So I will consider 2 electrons, correct? So lone pair. So I have 3 bond pairs and Ragul 2 lone pairs. So that makes the number 5. Now we know that 5, okay, you have to write down hybridization accordingly, your 5. So we know maximum s orbital we have 1, p orbital we have 3, d orbitals we have 5, correct? So the number 5 is there. I will start from S. Anthony, Ragul, look over here. I'll start from S. So let us say if number is 2, that means what? I have 1 S and 1 P. If the number is 3, that means what? Anthony, Ragul, I have 1 S and 2 P. If number is 4, that means I have 1 S and 3 P. If number is 5, that means now my P is over. My P is over. So what I have? S, P, 3, D. Those who are completed with it, kindly solve XeOF4 also. Okay. sp3d. Is it clear? Ragul, Anthony, is it clear? Kevin? Yeah. sp3d. sp3d. Ragul, Anthony, come on, give me yes. I hope it is clear. I am doing it for you again. Yeah. Okay. This is sp3d. Now sp3d, the geometry is TBP. Okay, geometry is TBP, that is trigonal bipyramidal. Now I want everyone to look over here for the shape. Come on, look over here. Solve XeOF4 after some time. Look over here. Kevin and everyone, Sindhuja, look over here. TBP is our geometry. Now geometry is different. Geometry is different for the compound. Over here we have geometry called as trigonal bipyramidal, that is TBP. But shape is different. In the geometry, we consider the lone pair. For example, everyone focus on the screen. For example, I have Xe, okay. So let us say I have A element. So how will my TBP look like? My TBP will be like A, A. Okay, that makes a triangle. So it is a trigonal, okay, that is a trigonal bipyramidal. This is a triangle, so trigonal, a pyramid at the top, a pyramid at the bottom. That makes a bipyramid. Ragul, Anthony, if I join this, it makes a pyramid. That's why we call it as trigonal bipyramidal. These are my axial bonds. Yeah, these are my equatorial bonds. Correct? These are equatorial and these are axial. Okay. Now this is the rule for the TBP. First, we write elements on the axial bond, and that also on axial bond, the more electronegative element will come first on our axial bond. Are you getting it, everyone? Yeah, the more electronegative element will come on our axial bond. Okay. Now what is my compound over here? Okay, my compound is XeOF2, correct? My compound is XeOF2. Now how will I draw it? Look over here. Look over here. Over here, how will I draw the shape? So I have Xe, okay. These are my axial bond. So who is more electronegative among them? Oxygen or fluorine? Kevin, and I want everyone to answer this. Rajna, Sindhuja, Ragul, Prashanti, Anthony, Kirtini, who is more electronegative in oxygen and fluorine? Who is more electronegative? Yeah, Kevin has answers. Archana, okay, Ragul, Sindhuja, Prashanti, yes, Bhuvneshri, Kirtini, who is more electronegative from oxygen and fluorine? Yeah, it is the fluorine, which is more electronegative. It is the fluorine which is the more electronegative, and that will come on your axial bond first. Then what is left is your oxygen, and you have the lone pairs. You have the lone pairs. Are you getting it? Kevin, Anthony, is it clear? This is my trigonal bipyramidal, TBP. But TBP is the geometry. TBP is not the shape. For the shape, Kevin, what do? We ignore the lone pairs. So we just write XeF, F. What does this look like? Double bond O. Doesn't this, like if you do your face like this, yeah, what you can see, if I do my face like this, yes, it looks like a T. Yeah, it looks like a T. Although you can argue, no, it is not a T, but yeah, this, if you do your face like this, I guess scientists must have looked at like that way, Kevin. Okay, so you all do not need specs. The scientists need specs because they called it as T-shaped. Okay, they called it as T-shape, and this is how we got our T-shape. Now, if someone asks you how it is a T-shape, you have to punch him on the head so that his head tilts like this. Yeah, and you can see the T. Yeah, so it is a T-shape, but the geometry is TBP. Is it clear? Everyone, come on, give me yes or no. Is it clear? Okay, those who have not written it down, please write it down, the shape and geometry. Come on, draw it. Everyone, after drawing it, tell me done in the chat box. After drawing this, tell me done in the chat box. Chemistry is so fun, no? Like, if I ask you genuinely, like, I do not want to disrespect biology, but what is more fun? Like, is it chemistry or biology? Yeah? I know you are the NEET people, the bio people, but biology, chemistry. Yes, Kevin, what is it? I am offended. In PG Kev. Oh my God. Okay. What we say? Uh, good save. Yeah. In PG it is chemistry, otherwise biology. In the TG chemistry. Uh, hmm. And same question if the bio teacher asks in TG it is bio, sir. Hmm. In TG it is bio. Okay. Is this clear? T shape, TBP? Yeah. Chalo. Now you have to do it. Ragul, Anthony, I expect the answers from you now. Okay. XeO₄. At least go till hybridization, Ragul. At least tell me the hybridization correctly. I want to see if you can do this. XeO₄. Come on, Kirtini, I expect answer from you also. Yeah. XeO₄. Tell me the hybridization first. Okay, very good, Anne. Okay, very good, Kevin. Very good, Sasha. Ragul, I'm expecting answer from you. Tell me the hybridization. Rajna, are you fine? Yes, Prashanti, the hybridization. Okay, correct, Kevin. Only three has answered. Come on, I know each one of you have understood. So why you're not answering? Come on. Okay, very good, Ragul. क्या बात है? Yeah. Octahedral is a geometry, not a shape. Kevin. Okay, look over here. XeOF4, correct? It is sp3d2. Why? Because 2, 3, 4, 5. I'll take it on another page. Wait. I'll take it on another page. XeOF4. XeOF4. Correct, Bhuvaneshri? Xe, how many electrons? 2, 3, 4, 5, 6, 7, 8. Okay, correct, Prashansi. 8 are the electrons. Oxygen is 1. Okay, oxygen is 1, correct. And fluorine 2, 3, 4. And 1 lone pair. So 1, 2, 3, 4, 5 bond pair and 1 lone pair. Correct, Ragul? 5 bond pair plus 1 lone pair. Correct. So that makes the number, Ragul, 6. And 6 means what? sp3d2. Now sp3d2 geometry is octahedral. Okay. sp3d2 geometry is octahedral. Now look over here. Yes, Kevin, but look over here. Over here, the rules are a little bit different. If you remember, in the TBP, we write the elements on the axial bond first. But in the octahedral, we write the more electronegative elements or the elements on the equatorial bond first. Okay, on the equatorial bond first. That is the rule with the octahedral. So I have Xe over here. So more electronegative elements, Ragul. Okay, 1 minute. Everyone who is saying pyramidal geometry, what will come on axial bond? Kevin. And who is saying square pyramidal, what will come on the axial bond? Will the O come or will the F come? Yes. And Kevin, will there be O or will there be F? Coincidentally, I have written O only over there. Look over here. In the octahedral, your equatorials will form more electronegative elements. Okay. But in the TBP, it is the axial bond which will have more electronegative elements. So F, F, F. This is my square. Okay. This is double bond O and a lone pair over here. And a lone pair over here. Are you getting it, Sajna? So remember, in the octahedral, we write more electronegative elements, Ragul, on the equatorial bond, not on axial bond. So this is the geometry octahedral. Shape, you do not have to write down the lone pair. So Xe double bond O, F, F, F. Yeah. So this is nothing but your square pyramidal. This is your square pyramidal. Is it clear? Come on, give me yes in the chat box. Is it clear, Ragul? Yeah. Is it clear? Ragul? XeF₄. Come on, draw it quickly. Draw it and done in the chat box. Done. Okay, done. Okay, now, okay, this was your XeOF2 and XeOF4. Similarly, tell me, okay, will you try the shape now? You have understood the TBP rule, you have understood the octahedral rule. Ragul, Sarjana, everyone, will you try the shape? I'm giving you 2 elements. I want the answer. Okay. I am expecting the correct answer. XeF₂, XeF₄. Tell me the shape. Go from bond pair, lone pair, hybridization, geometry, shape. Come on, go for it. Go for it. Exactly, you do not have to do anything different. Exactly same what we have done till now, Raghu. Okay, come on. XeF₂ and XeF₄. Okay, very good, Sajna. But go and find out the shape. I want the shape for this. First tell me the shape for XeF₂, then I'll move ahead with XeF₄. Okay, Bhuvaneshwari, very good. Go to XeF₂ shape now, Bhuvaneshwari. Go to XeF₂ shape. Ragul, what is the hybridization that you have got for XeF₂? Is the hybridization? Little bit concept finally has come. Otherwise, we were doing all theory. You were also bored, even I was bored. Ragul? Hmm. Okay, very good, Prashansi. Prashansi, I want the shape. Okay, correct. And I want to shape, everyone. Shape for XeF₂. It is interesting. I know chemistry is not interesting, but this shape is interesting. Yes, Bhuvaneshwari, very good. It is not L shape. What is L shape? No. How does that look like? Prashansi, how does that look like? We do not call it as what you will say, small L shape. You do not have to write everything by alphabet. It is in a straight, but I got it that you have understood. You have just written the name incorrect, but I have got it that you have understood. Go for XeOF4 now. Not XeOF4, sorry, XeF4. Yes, Archana, what did we get? Shape? What is the shape? Archana, by any chance you're listening to songs? No. Seesaw shape. Plus shape. No. SP3 to 5. Okay. Seesaw. Okay. Sarjana. We do not have to consider the lone pair. Yeah, we do not have to consider the lone pair. We have considered the lone pair. So if you ignore the lone pair, Sarjana, what is the shape that you are getting? Yeah? What is the shape that you are getting? Correct time? What kind of shape is this, Kevin? Yeah? Oh my god. Okay, I asked the shape to Kevin, you know what he has written? Straight. Kevin, I do not have any doubt on you. Okay. I know you are straight. Yeah. Okay. So the shape is not straight. I did not ask about you, Kevin. I know that. Okay. I believe that. Okay. So the shape, what we call, is a linear. Okay. Do not call it shape.
I have typed it also, sir.
What?
I have typed it also, sir. Like linear, I have told, sir. But it looked like a straight line, sir. So that
Okay, it looks like a straight line, yeah. So it's a linear, yeah. Same goes to Prashanti. Prashanti has told me L shape. No, Prashanti, I cannot go there and say small L shape. Can I say it like that? Yeah, small L shape. No, na. Yeah. So it is not straight. It is not small L shape. It is linear. Okay. So XeF₂. Ragul, did you get the hybridization? Ragul, XeF₂. Did you get the hybridization? What is it? Ah. Hmm. So 1, 2, 3, 4, 5, 6, 7, 8. So F, how many lone pairs I have? 1 lone pair, 2 lone pair, 3 lone pair. Correct? So 2 plus 3 is 5. 2 plus 3 is 5. 2 plus 3 is 5. 5 means what, Ragul? sp3d. Now sp3d is TBP. But we do not, for the shape, we do not consider the lone pair. So first I'll draw the geometry. Geometry is TBP XE. and we write the axial bond, yeah, the more electronegative elements, then the lone pair over here, lone pair, lone pair, yeah. But we do not consider the lone pairs, Rakul. So the shape is linear. The shape is linear. Okay. Okay. Bhuvneshri has answered for XeF₄. Prashanti has answered. Anne has answered. Only three answers. Come on, Ragul. I expect answer from you also for the shape. Come on, Sajna. Bhuvneshri. Bhuvneshri, focus. As soon as I talk something else or it is not about you, like you all, some of you, I don't know what is like, you have so much of gossip in your family, like that you want to discuss it in the class only. Yeah, especially girls. Yeah, I know. Even I like to do gossip. Okay, like I come to office over here. I come in the morning. Okay, like around 12. I go home by around 10. So mom has all the gossip stored, and we discuss that. I know it happens with you also. You come from the school, then you have all the gossip stored. What happened in the school? Yeah, you ate someone else's tiffin and everything. Someone else's tiffin was better than yours. I know every gossip is there. You want to discuss, but after the class, yeah. So what is the shape that you have got? Oh, Sajna, Ragul, Prashanti has got it. Kirtini, tetrahedral. No, it's not tetrahedral. For the octahedral, Sajna, what do we do? First, we write down the more electronegative elements on the equatorial bond. Okay. So for XeF₄, again 1, 2, 3, 4, 5, 6, 7, 8. F, 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 F. A lone pair, a lone pair. So F, 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 F. Lone pair, lone pair. So that makes us 1, 2, 3, 4 plus 2. That is 6. 4 plus 2 is 6. That makes us Sajna sp3d2. sp3d2, Ragul, it is nothing but octahedral. So if it is octahedral, obviously, as I told you, for octahedral, first we write down the elements on the axial bonds, correct? So over here, I'll write Xe. So first we'll draw, sorry, for the octahedral, so sorry, first we write down the elements on the equatorial bonds. So F, 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 yeah, and over here the lone pairs, two lone pairs over here. So over here, for the shape, yes, Prashanti, we erase them, we erase the lone pairs. So what I have got, everyone, it is nothing but Bhuvaneshri square planar. Is it clear, Sajna? Yeah, is it clear, Prashanti, Bhuvaneshri, Kirtini? Yes, Kevin, is it clear? Okay, chalo. What a time to end the concept. 8 p.m. Okay, let's take a break. Yeah, do not run away in the break. Okay, so let's. What is the time now? It is exact 7:59. So we'll continue exactly. I want you back over here by 8:09 so that we can start at 8:10. Okay. Yes, everyone is back. Come on, back in the chat box. Turn on your cameras. Come on back in the chat box. Turn on your camera. Kevin and Sarchna, Ragul, Prashansky, Akhilesh. Prashansky, Kevin, Ragul, Sarchna. Come on, can we turn on your camera? Okay, sure. Let us go ahead. Yeah, where were we? XeO, sorry, XeF₂ and XeF₄ is done. Okay. Now, one more. If I give you, okay, let us do this. Now, there is one exception also. Okay, there is one exception also. There is one slight exception. XeF₆. Can anyone find it out? XeF₆. Come on, find it out according to BACPR. XeF₆. What will be the geometry, Kevin? Keep your phone aside, Kevin. Yeah, XeF₆. I can say, Kevin, you must be using phone at nights also. A good charging point just beside your bed is what we all ask for, isn't it? Uh, XeF₆, come on, find it out the geometry. Find out the geometry, XeF₆. XeF₆. Is it? What is the hybridization? And what is the hybridization that we have got? Kevin, starts now. Then what is sp3d2 then? Yes, Kevin, what is the hybridization you have got? Sarjana, what is the hybridization? Kirtini, what is the hybridization we have got? Okay. Okay, sp3d3. Sarjana, what is the hybridization? sp3d3. Correct, sp3d3. So sp3d3, and actually sp3d3, everyone, the geometry, for sp3d3 is pbp. Okay, that is pentagonal bipyramidal. Okay, pentagonal bipyramidal. But over here, as I told you, there is an exception due to the noble gas. Okay, it is not pentagonal bipyramidal, which it should be. It is your distorted octahedral. Okay, it is distorted octahedral. Like I have Xe, F, 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 F. Okay, you cannot just write octahedral, and it is not a complete octahedral. Okay, apart from octahedral, like this is octahedral F6, we have one lone pair also, isn't it? We have one lone pair also. That lone pair is somewhere over here. Okay, is somewhere over here. That's why we say distorted octahedral. Somewhere below the plane we have that lone pair. So we say distorted. Write it down, the shape, distorted octahedral. Distorted octahedral. Distorted octahedral. Come on, write it down. Distorted octahedral. But also mention that generally sp3d3 is pentagonal bipyramidal. Okay, pentagonal bipyramidal. Like, what is pentagonal bipyramidal? Let us say this is my M. Okay, this is A. Suppose this is A, 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 A. Okay, so your pentagonal bipyramidal looks like this. Look over here. This is my pentagon. I hope it looks like a pentagon. Yeah, it looks like one. And A over here, A, P. This is our PBP. Okay, generally. But this XeF₆ is kind of exception. It becomes distorted octahedral. It becomes distorted octahedral. Come on, draw it and tell me done in the chat box. Draw it, write it down and done in the chat box. Come on, go ahead. Draw it and done in the chat box. Is it done? Sarchna? Okay. Kevin? Done. Prasanthi? Done. Kirtini? Done. Let us go ahead. Let us go ahead. Okay. Not go ahead. Let us come back. Okay. Where were we? Why did I tell you to do all these shapes? Okay. Now, it is very important. This reactions can come. Okay. Now, this we have already learned. Now, let us go through all the reaction we have learned about their shape, hybridization. Now, let us go to their reactions and the preparations. Okay. Now, XeF₂, XeF₄. Next we have is XeF₆. Common thing, like you only think about common sense. What are we doing? We are increasing the number of fluorine. Yes or no? We are increasing the number of fluorine. So what we will do? We will increase the ratio. We will increase the amount of fluorine. For example, look over here, Kevin. We have 2:1 xenon into fluorine. So I've got XeF₂. Then I'll increase the amount of fluorine. I have taken 1:5. I'll increase the amount of fluorine 1:20. I'll increase it further. I'll get XeF₆. Are you getting it? So as you go on increasing the amount of fluorine, you'll get first XeF₂ in 2:1 ratio, XeF₄ into 1:5 ratio, and 1:20 ratio will give you XeF₆. Is it clear, Sarchna? And is it clear? Okay. Structure we have already studied. Yes. Structure, hybridization, lone pairs, everything we have already done. Then we have the reactions. What happens if you hydrolyze it? See, simple logic. If you hydrolyze it, it is going from unstable towards stability. Correct? So I'll get the stable xenon. Okay, if I hydrolyze XeF₂, I'll get the stable xenon. Similarly, if I put it into base, again I'll get the stable xenon. I'll get the stable xenon. Okay. Same thing over here. XeF₄. If I hydrolyze it, what will happen? I will get xenon. And the fluorine is released and the H plus from it combines with it to give you HF acid. To give you HF acid. Are you getting it, everyone? Yeah. And if you do the controlled hydrolysis, if you do the controlled hydrolysis on very low temperature, that is -80, you get the xenon oxyfluoride. Come on, write down all the 4 reactions. I want you to write it down. Come on. We have time today, so write it down, the reactions. Xenon oxyfluoride. Yeah, write down all the 4 reactions and done in the chat box. Come on, write down the reactions and done in the chat box. Come on, done, done. Okay, chalo. Sarjana, is it done? Prashansky, done? Kevin? No or yes? No, acha, doing it. Do it. Kirtini, come on, write it down. Write down the reactions. These are the reactions if I do the hydrolysis with the xenon. Okay, of XeF₂ and XeF₄. Okay, if I do the hydrolysis of XeF₂ and XeF₄. Okay, chalo. 7 is also done. Let us go ahead. Then we have XeF₆, as I told you. Yeah. So look at the structure. Look at the structure. This is what your distorted octahedron looks like. Yeah. Although it is sp3d3, but it is not pbp, that is pentagonal bipyramidal. It is distorted octahedron. Yeah. Distorted octahedron. Now, if I have more amount of fluorine and if I do the hydrolysis, okay, if I do the hydrolysis, again, one thing is common in all the reactions. If you have noticed, yeah, fluorine you have and H plus you have from the water. HF. So your resulting liquid will be acidic. Is resulting solution what you are getting will be acidic. So if I do the hydrolysis, what will happen? Sarjana, I'll get XeO3. I'll get XeO3. And if I do again the controlled hydrolysis, again I will get OF4. Come on, write down the reaction for XeF₆. If I do the reaction of XeF₆, generally if I do the hydrolysis, I'll get the XeO3. That is xenon trioxide. Similarly, if I do the hydrolysis, come on, write down both the reaction and done in the chat box. I do the hydrolysis in a controlled manner in a nickel vessel. Okay, nickel is a catalyst over here. In a nickel vessel, we get XeOF4. Come on, write it down and done in the chat box. Write it down and done in the chat box. Write it down and done in the chat box. Kevin is done. Sarjana done. Okay. Prashansky, is it done? Okay. Sure. Let us go ahead. Okay. Okay. So over here, as I told you, everyone, xenon, they also are reactive. If you react with them, for example, over here we have fluorinating agents. Yeah. Over here we have fluorinating agents. Your xenon is acting as a fluorinating agent. Your xenon fluorides are acting as a good fluorinating agents. For example, it fluorinated the water over here to give you HF. It fluorinated water over here to give you HF. So xenon fluorides are good fluorinating agent. Remember this. So although look over here, you have PF5 and xenon fluoride. So xenon fluoride is so fluorinating agent that it will give fluorine to that also. So if it donates a fluorine, what will happen? XeF plus PF6 minus. Same over here, XeF4SB. What is SB? Which element? SB, Sarjana. Look over here. Focus. SB, which element? Prashansky, Bhuvneshri. SB. I asked you this in the last lecture also, if I'm not wrong. SB, which is the element? SB. Very good, Sarjana. It is what we lack. Yeah. Antimony. Yeah. Antimony. Antimony. Okay, antimony. So again, if I have antimony fluoride, again fluorine is donated, we get a complex. So basically the bottom line is the xenon fluorides are the good fluorinating agents. Yeah, good fluorinating agents, except When you have alkali metals, at that time your alkali metal will donate the fluorine. Okay. Apart from that, everywhere your xenon fluoride will give the fluorine. Come on, write down the reactions. Write down the reactions of xenon compounds. So it is a proof that xenon fluorides are your fluorinating agents. They are the fluorinating agents. Fluorinating agents. Fluorinating agents. Come on, write down the reactions are done. M, this M stands for metal. Okay, these are the metals. Sodium, potassium, rubidium, cesium. And write down the reactions. Write down the reaction and done in the chat box. Done, 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 done. Okay, can we go ahead? Yeah. Kevin, Prashanti. Okay, sure. Okay. Then these are your XeO3, XeO4. We did not calculate for this. We did not calculate for this. I want you to chalo. The last one. The last one. Okay. I will not do more VSCPR after this. XeO3. 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 Come on. XeO3. Xe. I know it is one of the rarest and it is one of the reactive from all the elements we have. In fact, only reactions we have is of xenon only. That is the chemistry for you, especially inorganic chemistry. Yeah. XeO3, what I want you to tell me the hybridization. I want you to tell me the geometry. I want you to tell me the shape. Okay, XeO3. Geometry, shape, hybridization. Geometry, shape, hybridization. Okay, geometry, shape, hybridization. Okay, okay, Sarsna. Geometry, shape, hybridization. Or in the order hybridization, geometry, and then shape. Hybridization, geometry, and then the shape. Okay, Bhuvaneshri. It is wrong, Bhuvaneshri. Check again. Bhuvaneshri, check again. XeO3. Okay, very good, Kevin. Bhuvaneshri, check again. Anthony, where did you go in between the lecture?
Sir, there was a power cut, sir, so I couldn't.
What happened? Come
There
again.
was a there was a power cut, sir.
Where do you see that there are so many frequent power cuts? Yes,
Sir,
Kevin?
in yes, sir.
Okay. Is there any frequent power cuts?
I don't know, sir. For half an hour or 40 minutes.
Exactly during dinner time there was a power cut.
No, sir. No, sir. I have informed the moderation team also, sir.
Okay, fine. Chalo. No issues. Come back. Do the XeO3.
Sir,
VSTP.
like VS theory was teaching like that time only current.
Okay, I'll teach you for this also. Come on. Others let others answer. I'll teach you for this also. Okay. Yes. Bhuvneshri, you are wrong in this. Come on, Bhuvneshri, what is the correct answer? Yeah. Sarjana, what is the geometry? What is the shape? Bhuvneshri, what is the hybridization? It is not sp3d. Trigonal planar. No, not at all. Okay. So look over here, everyone. First of all, understand the shape and geometry if you want. Okay, Bhuvneshri, it is correct now. SP. What is the geometry for SP? Yeah. Those who do not know, you can write it down. What is the geometry for SP? Yes, SP, what can, yeah, only one possibility we have is the linear. For SP2, what is a possible geometry? Sarjna, SP2, what is a possible geometry? Yeah, we have the carbocations also. Yeah, that is trigonal planar. Okay, trigonal planar. Okay, SP2, like it is like this. Suppose I have A, X, X, X. Trigonal planar. It is just like your TBP, but you do not have a pyramid. Okay, trigonal planar. Then we have sp3. sp3 is tetrahedral. sp3 is tetrahedral. sp3d we have already discussed. It is TBP. Yeah, it is TBP. Those who do not know, please write it down. sp3d2. Yes, we know that also now. Yes, correct. And that is octahedral. Correct. Then we have sp3d3. That also we discussed. That is pentagonal. Write it down by pyramidal. Pentagonal by pyramidal. Okay, these are all the geometry. These are all the geometry. These are all the geometry. Okay, these are the geometry. Okay, now over here sp3. Okay, look over here, Anthony, we were discussing what XeO3. Okay, first of all, is it done, written? Sarjana, come on, write it down. Kevin, done, written. Prashanti, written. Okay, Anthony, did you write it? Okay, chalo. Now I want Anthony complete focus. Look over here, XeO3. What we have got, where did it go? XeO3. So how do we do it, Anthony? Xe, it is a group 18 element. So valence electron will be what? Valence electrons will be 8. Correct? So I'll draw this 8 electron, Anthony. 1, 2, 3, 4, 5, 6, 7, 8. Correct? So I have 3 oxygen. So each oxygen forms 2 bonds. So 1 bond pair, second bond pair, third bond pair. Correct? And we have a lone pair. So the number is, Anthony, 3 plus 1, 4. 3 plus 1, 4. Correct? If you want, you can write number also over here. 2 for SP, 3 for SP2, 4 SP3, 5 SP3D, 6 SP3D2, 7 SP3D3. So number is 4, that is SP3. Number is 4, that is SP3. Now SP3 is the geometry, it is not the shape, Anthony. Correct? It is the geometry. Geometry is different, shape is different. So geometry is like this. I have xenon. Okay, geometry is tetrahedral. So oxygen, oxygen, oxygen. Okay, and a lone pair. And a lone pair. This is your geometry. This is your. Doesn't this look like a bonfire? Yeah? Your fire is burning. We are relaxing on the beach. Yeah. So this is your geometry. But Sarjana, in the shape, we do not consider the lone pair. So XeO, XeO, XeO. Doesn't it look like a pyramid? Yeah. Xe on the top. It is not in a single plane. Okay. sp2 is in a single plane. Tetrahedral means what? We have an atom over here. Okay. We have an atom. Look over here. We have an atom over here. Then we have atom over here, 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 and one at the top. That is, everything is out of plane. Yeah. Everything is out of plane. Nothing in plane. Okay. So over here, that's why it is pyramidal. So write it down. The shape pyramidal. For XeO3, the shape is pyramidal. I hope, Anthony, is it clear? Come on, Kevin, everyone, give me yes in the chat box. It is clear. Yeah.
Yes, sir.
Okay.
Sir,
And then
1 minute, sir. I will copy down, sir.
Copy, copy. Those who have not written, copy. Come on, copy it. And by the way, did anyone like I don't know exactly in the south. Do you all celebrate Janmashtami? Janmashtami, do you celebrate? I guess you must be. That is the birth of Lord Krishna. It was yesterday. Yeah, like we tie a what we say a bucket like of thing, what we call it as a pot. Yeah, and we break it. Over here, it was in full flow. Oh my god! Have you ever seen it? Yeah, have you ever seen it? No, have not. I'll show you if I have it. Okay.
Sir,
Yes, Anthony.
sir, in the geometry you have drawn the lone pair, sir.
Hmm.
Is-
Yeah.
So here that XeO, the bond, the pair that you have not drawn. So lone pair is necessary to draw.
For the geometry, you have to draw the lone pair, and that is how your tetrahedron look like. You have an element, okay, element at the top, element over here, element over here, element over here. That is your geometry, tetrahedron. But the shape, okay, in the shape, write it down, Anthony, we do not consider the lone pair. We erase the lone pair. Okay. Now that does not mean everyone, this goes to everyone. That does not mean you erase this lone pair. Okay, that will change the hybridization completely. So do not erase this lone pair, just erase it from the geometry, okay, from the drawing. So if I erase this, Anthony, this looks like a pyramid. Yeah,
Okay, sir, got it, sir. Thank you, sir.
okay, this looks like a pyramid. Okay, chalo. Okay, just a, just a minute. Is clear with this? Yeah, VSCPR. Yeah. So we were talking about pyramids. Okay, I'll show you your human pyramids. Yeah, we celebrate this on like look over here. We celebrate this every year. Okay, we call it as Janmashtami. Okay, that is the birth of Krishna. We celebrate like this. So this is the human pyramid that they form. Okay. This is just below my house. Okay, where do I stay? It's just below that. So look at them. They will form a pyramid like this.
चला सात थर घडत चला ठाण्याचा राजा आपला झेंडा पाठी घ्या आपला झेंडा तोडा पाठी घ्या त्यांची थर रेकॉर्ड होणार बस शांत बस फक्त 20 सेकंद करा फक्त 20 सेकंद करा चारही थर बसले तुमचे वरच्या चारही एकटे बसले चाल करा
Yeah. So it is very fun. Yeah, you know, when I was a kid, even I used to go to that every year. But now all grown up, and now we have to earn. You are a kid, you are lucky. Okay. Chalo. Come back. So that was a pyramid. This is also a pyramid. Yeah. So I have a xenon, oxygen, 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 xenon at the top. Just like that kid, how he was hanging. Similarly, a xenon is at the top like that. Oxygen, oxygen, oxygen. Okay. Clear everyone? The pyramid and the geometry tetrahedral. Yeah. Everyone is done. Clear, Anthony? Where were we? XeO3. XeO3. So look over here. So this is your structure. Same is XeO4. If you find out, instead of lone pair, you have one more oxygen. That makes it tetrahedral. Okay. So pyramidal structure, tetrahedral structure. Hybridization is same sp3. Okay. So if you look at the preparation again, this preparation we have already, you have written, yeah. XeF₂, if you hydrolyze it, this is the reaction of XeF₂, but the preparation of XeO3. Yeah. You have already written that XeF₂, when you hydrolyze it, what you will get? You will get XeO3. Yeah. XeF₂, if you hydrolyze, you will get the XeO3. Simple. Okay. Do not make it complicated. Reaction. If you put a base in this, okay, if you put a base, what will happen? Everything gets added. Your OH gets added. It becomes XeO4 minus. XeO4 minus. Okay. Same goes with XeO4. What happens when you take H2SO4? Okay. On or sodium or barium xenate, over here sodium and barium xenate, they act as a support. Okay. So what happens? You get XeO4. Okay. So when you react H2SO4, look over here, when you react H2SO4 either with your sodium xenate or barium xenate, which are your salt. Okay. Sodium xenate and barium xenate. Okay. These are your sodium xenate. Come on, write down the reaction. Write it down. Sodium xenate, that is Na4XeO6. If I react it with H2SO4, what I'll get? I'll get XeO4. Come on, write it down. I'll get the XeO4. Yeah. Same thing. If I react it with barium xenate, that is XeO6. Again, plus H2SO4. Again, XeO4. Come on, write it down and done in the chat box. Write it down and done in the chat box. Write it down and done in the chat box, everyone. Write down both the reactions and done in the chat box. Arsana is done. Come on, last few minutes, then we will be done. Okay, I know P block. This is the final movement of the P block. Yeah. So few more minutes. Then next lecture, I have told you we are not going to do any theory, but I'll give you some tricks and tips. Okay, in the next lecture, and also we'll do, that is the main point of the next lecture, to do all the questions. Okay, to do all the questions. Then we have XeOF₂. This is also we have done. Yeah, the preparation. If I do the reaction of XeF4 with water, if I hydrolyze it, and what I'll get the XeOF₂, and again HF. XeOF₂, T shape, we have already discussed it. Yeah, T shape, sp3d, PBP, 2 lone pair, everything is done. Yeah. Similarly, this also sp3d2 square pyramidal, everything is done. Yeah. So how do we prepare XeOF4? That also we have looked at. If we take XeF6, if we hydrolyze that, I'll get XeOF4. So once preparation or once reaction is others preparation. Yeah. Once reaction is others preparation, and that is how you have to remember the P block. Otherwise, it is very difficult to run. Yeah. Similarly, there is one more preparation. If I react it with silica, okay, if I react with the silica oxide, what is silica oxide? What is silica oxide? Anyone? Silica oxide. Yeah. What is the silica oxide? Yeah. Yes, obviously I know it is SiO2. It is written also over here. If I ask you what is sodium chloride, you will not say NaCl. Ha, correct. What is SiO2? Yeah, Sarjana. It is what we used to play when we were kid. Yeah, we used to play in that. Now also some of you might be playing in that. Yeah, what is SiO2? Yes, Kevin. SiO2. Prashantji. Where do we find SiO2? Kirtini, Bhuvaneshri. Yeah, it is nothing but a sand. Okay, SiO2 is sand, silica oxide. Okay, the sand, the primary constituent of the sand is silica oxide. Is it clear, Sarjana? Yeah. So simply what we do, we take the XeF₆, we add sand into it and we heat it. Simple. Okay, we get XeOF4. Yeah. Now write down this also important. XeOF4, if we further hydrolyze it, if we further hydrolyze this, yeah, what will happen? I'll get XeO2F2. Come on, write down first important reaction. First reaction is important. XeOF4, if I hydrolyze it, what I'll get? I'll get another XeO2F2, which I further hydrolyze it, I'll get XeO3. Come on, write it down and done in the chat box. XeOF4, if I hydrolyze it, I'll get XeO2F2. Yeah. If I further hydrolyze it, I'll get XeO3. Come on, Kevin, write down and done in the chat box. Done. Sarjana, come on, go on. Done in the chat box. Kirpini, Ragul. Come on, done in the chat box. Done. Okay, inshallah. Then the last one, XeO2F2. Yeah, XeO2F2 reaction we have already seen. We have seen the, no, we have not done the VSEPR for this, no, XeO2F2. If we do it, what we will get? XeO2F2. That is your, yeah, again, you have to tilt your face like this. Yeah, tilt your face like this. What does it look like? I'm not asking how does it look like straight. Yes, it looks like a K. I know you will say it looks like a K. But if you tilt your face, okay, if I tilt this, it will look like what? Yeah, what does it look like that we used to play? Yeah, sitting over here. Yeah, remember your childhood when you never used to study so much? Yeah, when we had only one science book and not physics, chemistry, maths, biology. Yeah, Kevin? Yes, it is the seesaw shape. Okay, it is called as seesaw shape. Okay, it is called as seesaw shape. Okay, seesaw shape. So XeO2F2, how do we get it? If I hydrolyze, we have seen this reaction. Okay, if I hydrolyze XeO3, what I'll get? Oh, sorry. If I react XeO3 and XeOF4, we have seen this reaction. Your XeOF4 act as a fluorinating agent. Yeah, and we get XeO2F2. Yeah, XeO2F2. Again, we can get it with the help of silica also. Okay, and if I do the hydrolysis, further hydrolysis will give me XeO3. Is it clear till over here, everyone? Yeah. Okay, almost done. The last part, I guess, yeah, uses. So uses. Okay. So helium, yeah, helium. Anyone? Okay, helium balloons. Yeah, we have the helium balloons. We love it so much. Even being an adult, I used to buy the helium balloons for myself. Yeah, because I love it. Helium balloons. It feels so nice when all balloons are there, isn't it? So your helium is lighter than the air. Obviously, it will go. If you leave it, it will go up, 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 and that is where your important use is there. What is this meteorological observation? Anyone? Meteorological observation. Yeah? Meteorological observation. What is this meteorological? About meteors. Oh, is it? Come on, everyone, tell me. What is a meteor, by the way? Yeah? What is a meteor? Meteorites. What is it? What is a meteor? Yeah. I go for stargazing. I do not have the photos now, otherwise I could have showed you. I've showed you that I go for every year. Okay, at least thrice or four times I go for a stargazing where we go in a pitch black jungle. Okay, and when we observe the sky, it is so beautiful. Okay, we go on the meteor shower day generally when like in a single night, at least 15 to 20 meteors is the minimum I see. Minimum. Okay, it is the minimum. It is beautiful. You all also should go. Okay, but not now. After your 12th. So meteorological means what? It is not that meteors. First of all. Okay, meteorological, correct, Kevin? It is your weather. Okay, like what happens is meteorological means we leave this balloon. Okay, so that it goes in the atmosphere, it goes on the top, and we attach some instruments. Okay, to measure the temperature over there, to measure anything that is around that area. Okay, that is a meteorological. We study about the weather and the climates. Okay, then helium oxygen mixture. Everywhere helium oxygen mixture. Even the sea divers have the helium oxygen mixture, yeah, to avoid the pressure. Then we have liquid helium as a transfer agent for creating. This should be not inert, this should be inert, yeah, for creating inert atmosphere, obviously. Then neon, yeah, neon, we have seen neon signs, neon bulbs. Anyone have seen what we call those fireflies? Anyone have seen? Sarjana, have you seen fireflies? Prashanti, Kevin, have you seen? Like in real life, I am saying, obviously, on the televisions and YouTube, you have definitely seen, but in real life, have you seen? It is so beautiful. Again, like generally, you get to see that around the month of May end or June beginning. Okay, at that time, there is the breeding season of those fireflies. Okay, like again, I go for stargazing, I go for fireflies hunting, like not hunting, but to see. Okay, so we do go for the trekking. I see the fireflies and all that. Okay, it is beautiful. Once I had gone to the trekking at that point. Okay, at one point like around 2 a.m. to 3 a.m. there was a tree, complete dark, but that tree was illuminating. The whole tree was covered with fireflies. Imagine, it was beautiful. Okay, so basically the point is we have neon signs, we have neon bulbs, yeah. Then we have sodium vapor lamps, safety signal, okay, not so important. Electric bulbs, okay, go through it once afterwards, okay. Then we have xenon. Radon is used for the treatment of cancer. Radon is radioactive, yeah. Radon is radioactive, hence it is also used in X-ray photography, yeah. It can release X-ray, it is used in X-ray photography, okay. Importance in radioactive research, okay. I hope everyone is clear with this, yeah. Everyone is clear till what we have done.